Good evening, ladies and gentlemen. This video is designed to help you with the final review packet questions 58 through 63. Covers some of the information on molarity and calculating boiling point, freezing point, and vapor pressure. I want to apologize if this video is a little crude. I'm trying to get this out really quickly because the question was asked about 15 minutes ago, and I want to try to be able to help as best I can. Alright, so question 58. Question 58 is asking us what is the concentration of carbonate ions in each of the following solutions. So I'll walk you through 58A. 58B is exactly the same thing, just with a different compound. And it's asking us about the carbonate ion. So first thing to note is this is an ionic compound. We know this is an ionic compound because we have our metal with our non-metal. When ionic compounds are placed in water, they dissociate. So this would break up into its ions. Aluminum with a +3 charge, and carbonate with a -2 charge. Next, you would have to balance it. You would see here that you have two aluminums on the left side, so we put a 2 in front. We have 3 carbonates on this side, so we put a 3 in front. The problem tells us that we have 1.75 molar solution of aluminum carbonate. Remember though, once you place it in water, it is no longer aluminum carbonate. It's its ions, aluminum and carbonate. And ultimately, we're trying to find the carbonate ions. You see here that you have a 1:3 ratio. So that tells us you have 3 times as much carbonate as you do aluminum carbonate. So we take the 1.75 and we multiply by 3. That gives us an answer of 5.25 molar concentration of carbonate ions. And that is all you have to do. So remember guys, it's an ionic compound, so it dissociates. Multiply the concentration by the coefficient. 58B is exactly the same, except it's asking you to start with sodium carbonate instead. So make sure you do the dissociation, then multiply by the coefficients. So the next problem, question 59. Question 59 is asking us to calculate the mole fraction of salt in the following solution. A solution that's made up of 32 grams of magnesium chloride and 338 grams of water. So we know that we're going to be using the mole fraction formula. We know that we're going to, for the first one, because A is asking us for the mole fraction of the salt, which is magnesium chloride. So we know that the solute is MgCl2. And that the solvent is water. Remember guys, the solute is always what's being dissolved. In problems like this, the solvent will always be your liquid because it's what's doing the dissolving. Sorry about the blurry camera, I can't do much about it right now. So the first thing we need to do is we know the formula is asking us for moles. So we need to convert our grams to moles. Remember, to convert to moles, we divide by the molar mass on the periodic table. You will do that by adding up the mass of 1 magnesium and 2 chlorines. When you do that, it comes out to 95.211. We do the same thing for water. We need to divide by the mass on the periodic table. Remember, the mass of water is 18.015 grams. That might be worth writing on your index cards because we use water a lot, and that way you won't have to calculate the mass. When you divide, but yes, you are dissolving, you find that you have 0.34 moles of magnesium chloride, and that you have 18.76 grams. Like I said, sorry guys, it's going to be a little crude. I don't have time to remake it since the question was asked really late. Moles of H2O. So now we just plug into our mole fraction formula. So we know that the solute is MgCl2, and that's what it's asking us for. The mole fraction of MgCl2 will equal the moles of MgCl2 over the moles of magnesium chloride plus the moles of water. When you solve this, it comes out to 0.1, when you solve this, it comes out to 0.018, and that is your mole fraction. Remember guys, on mole fraction you have no units. So then when you're working on B, you can do B 2 ways. Because this time it's asking about water, which is the solvent. You can use the reverse of the formula, which is the mole fraction of solvent equals the moles of solvent over the moles of solute plus the moles of solvent. Or you could remember that the mole fraction of the solute plus the mole fraction of the solvent will equal 1. So we can easily plug in our 0.018 plus x of the solvent equals 1, and then we can solve for the mole fraction of the solvent by subtracting 0.018 from both sides. That would give us our mole fraction of the solvent equals 0.982. Again, you can solve it either way. I would probably write down both formulas just in case I ask you for the solvent and you didn't have to calculate the solute first. For example, in a multiple choice question, that is possible to show up. Next, question 60 is asking us what is the mass percent of calcium chloride if 45 grams of calcium chloride is dissolved in 320 grams of water. So we focus on the word mass percent. That tells us to use our mass percent formula. The mass percent equals the mass of the solute divided by the mass of the solute plus the mass of the solvent, all multiplied by 100. So when you look back at the problem, it tells us 45 grams of calcium chloride is dissolved in 320 grams of water. So we need to just determine what these are. Remember, calcium chloride is the solute because it's being dissolved. Water is the solvent because it's what's doing the dissolving. So we would plug our values in. Where it says solute, we'll put 45. Where it says solvent, we'll put 320. All of that is multiplied by 100. To solve this, you just type it into your calculator, and you should get 12.33%. The next question, 61, is also a mass percent formula. 61 is asking us, I'll wait for it to focus, or try that again. 61 is asking us how many grams of calcium nitrate needs to be added to 400 grams of water to make the solution as 47.5% mass by calcium nitrate. So what we need to do is we plug in the 47.5 where it's the mass percent. We need to solve for the mass of the solute, mass of calcium nitrate. So instead of writing mass of the solute, this is where I will write an X. And then it tells us the mass of water, which is 400. So we add it to 400. All of that is multiplied by 100. Now it's just an algebra problem where you need to solve for X. So the algebra can be a little tricky on this one because you have two variables. So to solve this, the first thing we do is divide both sides by 100. Cancels out. We get 0.475 equals X divided by X plus 400. Next, this is just a problem that we solve throughout the year. Remember, guys, this is really divided by 1, so that allows us to cross multiply. So on one side we get X, the other side we get 0.475, and then in parentheses X plus 400. Now we have to distribute. The 0.475 will be times X and by 400. So once we do that, we get X equals 0.475X plus 190. Next, remember guys, that there really is a 1 in front of this X. So to solve for X, we have to get X's on both sides. Whoops. So we subtract both sides by 0.475X minus 0.475X. They can set X's to cancel out on one side, and then we get 0.525X equals 190. Then, to solve for X, we divide by 0.525. That gives us X equals 361. I have the answer somewhere. 361.90 grams. And then that is how you solve 61. Next, question 62. We're trying to find the total molality of all particles in a 1.75 molar solution of sugar. Remember guys, sugar is a covalent compound. In the problem I tell you that it's covalent, but remember, we know this is covalent because we have all non-metals. Remember guys, this relates back to question 58. Only ionic bonds dissociate in a solution. So what that means is sugar is covalent, so it will not dissociate. Because it doesn't dissociate, the molality in the beginning equals the molality at the end. So our molality stays 1.75. So it's kind of like a trick question, but it's also just testing you to make sure that you understand only ionic bonds dissociate in water. And the last question I was asked about was number 63. So a solution was prepared by placing 72.8 grams of magnesium chloride in 120 grams of water at 22 degrees Celsius. The vapor pressure of the water at 22 degrees Celsius is 2.6 kPa. So A and B go together where we're kind of calculating the boiling point and the freezing point. Remember, there are a couple formulas you'll need to know. For the change in boiling point, you'll know that it equals the total molality divided by the boiling point elevation. And then the freezing point equals the total molality times the freezing point elevation. So to start this problem, remember magnesium chloride is ionic. So magnesium chloride, when it breaks up, it will break up into magnesium with a positive 2 charge and chlorine with a negative 1 charge. We need to put this 2 in front right here because we have 2 chlorines in magnesium chloride. So the first thing to calculate is MT. We need to calculate MT, and you can use it for both A and B. You don't need to calculate KBP or KFP. Remember, those values are constant. They never change. So again, something really important to make sure you write down on your index cards. I'll give you those values once we get there. So remember, guys, the molality is equal to the moles of the solute over the kilograms of the solvent. It does not give us moles of the solute, but it tells us that we have 72.8 grams of magnesium chloride. Remember, guys, to solve for the moles, we divide by the molar mass. The molar mass of magnesium chloride is 95.2, I wrote an extra 1, 211. Remember, we calculated that on an earlier problem, but if you don't remember how to calculate it, it's the mass of magnesium plus the mass of 2 chlorines. Sorry about the blurry table. There is not much, the blurry sheet, I think it's because my table is moving around. There's not much I can do about it right now. So once we divide that, we come out and we have 0.76 moles of magnesium chloride. So next we would have to plug that into our molality formula, which we have right up here. So we put our 0.76 moles over our kilograms of the solvent. So remember, it tells us, 1 second, try to get it. So remember, it tells us we have 120 grams of water. So to convert to kilograms, we move the decimal place to the left 3 places, which is the same as dividing by 1,000, not 100, divided by 1,000. So we have 0.12 kilograms of water. So that's what goes on the bottom. Once you divide, you find that we have 6.33 molality of magnesium chloride. So next, we need to find the total molality. Remember, guys, once you put magnesium chloride in water, it's no longer magnesium chloride. It is magnesium and chlorine. So to find the total molality, we multiply by the coefficients and then add together. So for magnesium, we do 6.33 times 1, and that is added to 6.33 times 2. Once you solve that, we find a total molality of 18.99, and that is our MT. So now we have our MT that we'll use for A and B. So now we just need to plug into our delta BP equals MT times K BP. So we plug in the 18.99 where it says MT, and then we have our boiling point elevation constant. Boiling point elevation constant is 1.853. Once you multiply these together and solve, we find that we have a change in boiling point of 35.19 degrees Celsius. Remember, guys, this is talking about the boiling point. Remember, water normally boils at 100 degrees Celsius, and this is just the change in temperature. So how much the temperature changed, how much the temperature was raised. So to solve for the new boiling point, we need to add it to 100. So then that gives us a new boiling point of 135.19 degrees Celsius. So then next, when we're calculating B, the freezing point, the change in freezing point, we can use the same total molality. So we'll plug in our 18.99. Then we just need to remember our freezing point elevation constant. which is 0.515. Then, once you multiply this together, it comes out to 9.78 degrees Celsius. The freezing point is a little different. We don't add it to 100. This time, we add it to 0 because water normally freezes at 0 degrees Celsius. And remember, this is the change, how much it changed. So we know our new freezing point is 9.78 degrees Celsius. Lastly, part C. Part C is asking us to calculate the, the vapor pressure of the solution. So you have to remember that this formula, P solution equals X solvent over P solvent. So this is the vapor pressure. This is what you are solving for. Remember, X is just the mole fraction. And then P solvent, this is given to us in the problem. If we look back at the problem, wrong problem. If we look back at the problem, it tells us that it's 2.6. So we know that that value is 2.6. Now we just need to calculate the mole fraction of water. So we know that the mole fraction of water is X solvent, so it will equal the moles of water over the moles of magnesium chloride plus the moles of water. We already calculated the moles of magnesium chloride up here. This is 0.76. So where it says moles of magnesium chloride, we can put our 0.76, and then we just need to calculate the moles of water. So remember, guys, we have 120 grams of water. So then to solve for the moles, we divide by the molar mass. Remember, the molar mass of water is 18.015. Again, that's probably worth writing on your index cards because we use the mass of water so much. When you divide, you get 6.66 moles of water. So now we can plug in the 6.66 where the moles of water goes. So 6.66 in the numerator, 6.66 in the denominator. Once you solve this, it comes out to 0.897. So now that is the value that gets plugged into where it says X of the solvent. So when we solve for this formula, it comes out to 0.89897 times 2.6. When you solve for this, we find that the pressure of the solution equals 2.34 kPa. And that comes right down there. So I hope you found this helpful. It answers questions 58 through 63. If you have any more questions, please try to stop in before school, and I would be happy to help you further. I hope you have a great night. Happy last minute studying.